Here we go with page 5. First off, you guys, we're looking at slope of this graphed line. If we're on a graph, we have so many options. Can anybody help me out? And what's one way that we could try and find the slope of a line if we have it on a graph? Has anybody got any ideas? Leo, if you have an idea, I'm going to mute myself so you can contribute. I want everybody hearing your brilliant voice. Leo has an idea.
Finding rise over run.
And how do we do that?
You go to, I think it's the lowest point on the graph, and then you go up to the highest point, like just straight up, and then you go like either left or right to it.
So Leo, I'm unmuted again. So I don't see any points. Do you see a place that we could, because you're talking about going from one point to another. Do you see a point somewhere on this that we could use?
Yeah, use this one, and then go up, and then across.
Oh, so because the big important thing is make sure we find a good, accurate point that's right on one of the grids. Are you thinking this one's one right here? I don't like the arrows, so let's try and find a place where, what about right there at that 4? Oh, yeah, there's a point. I think that we have a good one there as well. So just please, everybody, understand, it doesn't matter whether we find the 2 points closest to each other. So if we have the graph, we can physically count rise. We can physically count run to produce a slope. All right? So if we're using this point, Leo, are you able to figure out how far we rose?
I did not actually count it. It's very small on my computer.
I think I counted 5 units to go up. Are you able to count the run?
5, 4.
So we went up 5. Is that positive or negative?
Positive.
We went up 5, so the rise would be a positive 5, and we went to the left 4. Is that going to be positive or negative?
I think it's positive just because it doesn't go. No, it's negative because it goes left.
Yeah, right is always positive, left is always negative, up is positive, down is negative. So we are going to the left 4. Is this fraction, because we would always want to reduce a fraction if we could. Is this going to reduce any further?
Yes.
Can you think of a number that divides into 5 that also divides into 4?
1.
Anything besides 1?
No.
Then this is probably the most reduced slope that we are going to be able to find here.
That's probably correct. I'm just thinking though, it's a mixed. It's the number on top is larger than the number on the bottom.
Right, and we wouldn't want a mixed number because we literally want to know the rise over the run. So improper fractions are perfectly fine.
Okay.
All right, and honestly, mixed numbers are a difficult thing in an application type phase from here on out. Really, mixed numbers are helpful for valuation mostly. All right, so all we need is a point on this graph as well. Leo, did you see which one of the points did you want us to plug in to get this part of the answer?
Why don't we do the point that we used for rise? That I can't really read those numbers. Is that?
Looks like it's
4, 0.
4, 0. If we have a point and we have the slope, we can reverse the process and graph if we didn't have a graph. Try and remember, you guys, one thing that I would have access to heading into this test would be the slope formula. Some of you guys have been writing formulas down along the way in your notes, which is an outstanding thing to be doing. I would keep that process going. How do you feel about that, Mr. Spake?
Pretty good. I thought we might point out there's something nice about those 2 points you picked. They have names, right? Do people recall what those names are from Algebra 1?
Does anybody know that what we call this point that happens to run into the x-axis?
Coach, I might be wrong, but isn't it the 0?
It would. So when you start to progress further into Algebra 2, a point on the x-axis would actually be called a 0. But you're going way ahead of things here. We want to kind of back up and go simpler. How about this, Ryder? Do you know what we call the point that runs into the y-axis? Because that's not what we would call a 0.
The y-intercept?
Yeah. So what's the other one called?
X-intercept?
Yeah, so these are simple points. If we have access to them, the x and y intercepts are great, valuable tools. But we could have used any 2 points. We just want to make sure they're 2 accurate points. Okay? Fantastic. I love it. Let's continue. Now they've moved us on into a transformation. If we translate using this notation, what translation would move the image back to its original position? I need somebody's help besides Ryder and Leo.
No.
What kind of a transformation would move us back to where we started?
I have a question.
Leo's got a question first while everybody's thinking about how they're going to help us answer this.
Is it asking for the name of the transformation or the actual process of the transformation?
Well, let's try and Leo's trying to say, well, what are they actually asking about here? Let's read it again. So a figure is translated here. What translation would move the image back to its original position? So we're looking for something very specific.
The name.
I don't know about a name.
No, the numbers. The numbers.
So, well, first off, can anybody tell me where this translation is actually moving our object? Aaron, do you have any idea where this is moving an object?
To the left 5 and up 4.
Gosh dang, you're smart. This x minus 5, that's our horizontal movement. If we went -5, we're going to the left 5. The y value, that's my vertical movement. If we're going +4, we're going up 4. So, Aaron, what type of translation would move us back to where we started?
Right 5 down 4.
That's the idea. And if we're going to write it using the same notation, remember this beginning idea here means every point needs to move. And we just want to go back to where we started. We want to go to the right 5. Down 4. This is the type of answer we'd be looking for on a test.
I wasn't sure if it wanted me to give them numbers or.
So, Leo, does that make sense? It's not necessarily, because when you were saying a name or a number, it's really looking for a mathematical.
That's what I meant by numbers.
Yeah, we're looking for like a mathematical notation or communication on where we would need to move.
Yeah.
All right, so here we got some simple matching. We should be able to do this nice and quick here. Let's see if we Carolyn, I need your help, Carolyn. I know you almost get to class before everybody else, but I need your help, Carolyn.
Yes.
41 says a transformation that slides each point of a figure the same distance in the same direction. Is that a translation, rotation, reflection? Which one slides? What do you think? I give you full permission to be wrong right now if you want to. I'll give you a hint. We didn't even study dilations yet. That's actually next semester. So please don't choose D.
Translation.
Yeah, that's a slide. Stay with me because we're going to get all these done real quick. A transformation that spins. Which one of these spins?
Rotation.
I knew you knew these. You're so smart. And which one of these is going to flip items across a line?
A reflection.
There you go. We're crushing it.
Could you move the paper down a little bit and then pause for a sec?
I'm moving it.
Yeah. Back to where you were. You weren't. Oh, never mind. I was just zoomed in.
There we go. All right. Carolyn's crushing it. Frank, you there, Frank? Come on, Frank. Frank, look at 44. Which one of those transformations is going on right here? We had this point B that was here. Something happened to this hexagon, and now the image of B is down here. What do you think, Frank? Did we slide the object to get down there, spin it, or flip it? Come on, Frank, where you at? Don't dodge me, Frank. Kristen, can you help the kid out? He's trying to. I don't know if he's hiding behind his computer, but maybe he already went to lunch because, man, I'm hungry too. Kristen, what do you think?
Flexion.
Yeah, I don't think any other, because if we just did a slide, point B would still be up here at the top, wouldn't it?
Yeah.
I don't think if we did a 180-degree spin, I think point B would be down here. So I think the only answer is what you came up with. That has to be a reflection. Now, a topic that we just got done covering. We just took a test over this. So we should be all over this, right, Beatrice? Beatrice, where the heck are you? Man, I'm striking out on kids being here in the classroom. Anaya, I need some help, Anaya. I need to try and understand what the heck an angle bisector is and how I would find it on this diagram.
I don't remember.
Do you remember what bisect means?
Cut in equal parts.
You did it. That bisector means we got to cut in half. So somewhere on this diagram, somewhere we have cut an angle in half. Do you have any idea where on this diagram they're trying to tell you that an angle was cut in half?
BD.
Yeah, it's right here. It's right at point B, so that the angle bisector, you got it. That's got to be segment BD. I love it. Allie, do you remember what a median is?
Yes.
What's a median?
It connects the midpoint of one side of the triangle to the vertex on the opposite side.
Fantastic. You have the definition down pat. Where do we have a midpoint connected to the opposite vertex?
EC, segment EC.
There's the only place that we have a midpoint, because we would need to know that this segment equals this one. And then it's connected to the opposite vertex, EC. This is certainly going to be a test on your exam. Now all you've got to do is find the altitude. Gabby, where's the altitude?
Segment FA.
Yep, altitude's got to have a perpendicular relationship, and it has to hit the vertex. You said segment FA. Now, here we go into the more application idea. If EB measures 12.5, we'd want to find the measure of AB. David, do you have any idea what AB would have to equal? Or how we'd figure it out?
I think it would be double of what 12.5 is.
I totally agree, because 12.5 and this other piece has got to also be 12.5. Do you know what happens when we double 12.5? What would you like me to hold on to?
maybe 25.
You want me to hold on to 25? Or you going with an answer?
Oh, no, I was just saying that. Hold on, but
Kids tell me to hold on to stuff all the time in class. I always feel it's weird. Normally I just kind of grab the nearest thing, but sometimes chairs. Try not to grab students, they don't like it when I do that. So, but that was a fantastic answer. I love it. All right. So let's see here, because Elena, I got a tough question for you, Elena. This is a question that I often find brilliant students don't know the answer to. Elena, are you there?
Yeah, I'm here.
Where the heck is angle ABD? Because I have so many teenagers that are in my class that have no idea how to find that angle over here.
Well, it's half of ABC's here.
Where's ABC? Is it at the top, at the left, the right, the bottom, the in, the out? Where can you use some of those descriptive words?
A is at the bottom left.
No, I know where the letters are, but you said it's angle ABC. Where is that angle?
At the top.
Okay, but you understand there's kids in this class that don't know where that angle is. You're absolutely right. That middle letter really defines and narrows down the location. Angle A, B, D is this angle right here. It's at the top, but we only want the one on the left. If that angle is 34.3 degrees, how are we going to find the entire angle, which is ABC?
You have to double it.
Yeah, we're playing these simple games. I really hope everybody looks forward to a problem like this. What's 34.3 doubled?
68.6.
That's what I got. I'm not saying you're right. I'm just saying we got the same answer. I hope we're okay, because I think if we got it wrong, Mr. Spake would yell at me. Leo, you have a question?
No, Beatrice wanted me to tell you that she had to go to the bathroom, and that's why she answered.
Beatrice, we don't use the bathroom in the class. You just stay here and do math all day. All day. We are on to the next page, everybody. Keep up, because we're trying to take care of some business here. We're learning along the way. We're taking care of some work that might take you a long time. I hope you're keeping up. We got to keep it moving, though. Beatrice, where are you at?
She might still be in the bathroom.
Beatrice, you're killing me, Beatrice. Come on. We got to keep moving. Torin can help me out. Torin, are you there?
She said she didn't.
Yeah.
All right. You see problem 50 here?
Yes.
Do you see there's a typo? I have no idea where these answers came from. All these answers say there's some coordinate points. That is certainly not going to be the answer to X. How in the heck are we going to find the value of X on this problem, Torin, if I know two sides of a right triangle?
You get the square root of 6 squared times 3 squared.
What the heck are you talking about? You speaking crazy stuff?
I don't know.
I don't know either. What is it? Why are you squaring stuff and square rooting stuff? Why are you heading that direction?
Because of the Pythagorean theorem.
Oh, now you're talking smart. The Pythagorean theorem, what is that again?
A squared plus B squared equals C squared.
Oh, yeah. A squared plus B squared equals C squared. Dave, is that better?
Ah,
Hopefully that is better for Dava. So how do I know which number goes where, Torin?
So C is the hypotenuse, so it's
And
X.
how do I know is there an easy way to know which side is the hypotenuse?
Longest. Oh, it's the opposite from the 90 degree.
Yeah, that's something I always try and remember. The 90-degree angle is always going to point at the hypotenuse, the longest side, just in case you get confused, you guys. So that has to be C. Does it matter where I put 3 and 6?
No.
No. So where do you want to tell me what to? Well, let's plug them in because we're going to go slow. You were going way too fast for me. I was having trouble keeping up with you. But where am I going to plug 3 and 6 into? What do I want to do?
Okay, so 6 will be a squared thing.
6 squared,
Yes, and B will be 3.
3 squared. Are you going to put anything in for C?
No.
Okay. So just leave it as C.
C squared, yeah.
All right. What's our next move?
So you get 6 squared,
Do you know what that is?
36.
Gosh dang, you're smart. What's 3 squared?
9.
What's our next move?
You add those together, which would be 45. And
Now-
then you get the square root of it
Oh, why are we square rooting?
because it's C squared.
Oh, yeah, I don't want to know what C squared is. I want to know what C is. So we got to do an opposite operation. We're going to square root both sides. All right. And in the geometric world, because this is going to freak you guys out a little bit, but if we apply a square root on both sides, technically we should be getting 2 different answers out of this. But in the geometric world, when we're looking at lengths only, then we're going to look at the positive answer. Do you know the square root of 45, Torin?
6.7.
So if we could either, do you understand that we could either leave our answer like this, and we would be extremely accurate. We could plug it into a calculator. The calculator said it was about what?
6.7.
It's about 6.7. These are all kind of, we would want to watch our instructions here. We weren't really given instructions, so we have some freedom on how to produce that answer. And next semester, we're going to work on a concept called simplifying radicals. You don't have to hurt your giant brain right now, but Torin, that was fantastically done. Let's continue.
So what answer choice would you have chosen?
I personally, anytime that I can, I like to avoid rounding. I love precision. I personally would have gone after this answer. All right. Because I feel like the more we round, we start learning. I always think of architects. If they're not hyper precise, then they start building houses that kill people.
Why are all the answer choices points?
I already marked them off because there was a typo. I don't know why those answer choices are there.
So don't. Okay.
I'm trying my best to get you to ignore them. There must have been a process in converting because most of these problems we got from the exam itself. And so some sort of typo caused these to show up. Let's move on to problem 51. If a line contains these 2 points, which of the following points, this might be the potential answer to 51. There's our issue, and I just marked them all out. Let's see our options. -4, -2. They're asking which of these points would be collinear with the 2 that I gave you. We have 2, 1, and then we have, what was that? 6, 5. Now they gave us a hint. Let's graph it. Let's take a look. I got a graph right here. If we have 1, -2, and we have 3, 2, we have a line here that we can go ahead and does anybody have a guess as to which of these points might be our solution? Let's just take a look real quick. It's okay to take the time to investigate every possible answer. -4, -2. Do you guys think that's close enough? Hopefully you're saying no. That's not anywhere close. Point B, 5. 1, 2, 3, 4, 5. Ooh. Point B. We have 2, 1. Ooh, that's close. And then we have 6, 5. Anybody got a vote which answer we should kind of go with? Ryan, what do you think, Ryan? You going to go with A, B, C, or D? I know it's a tough choice.
I'm trying to think right now.
This was my little attempt to see if you're following along with me. Are you getting lost?
No.
Okay.
I understood the last few problems.
Okay. What about this one? Did you see that we're working on problem 51 here?
Yeah.
They gave us 2 points. I actually graphed those points on this graph. And they asked which of these points would be collinear with the 2 points that were given. Do you see point A over here?
Yeah.
Do you know what collinear means, Ryan?
Not fully sure.
So what do you think linear means?
Like in a line.
Yeah. Co just means together on a line. So the question is point A, point B, point C, or point D collinear with the 2 points that I gave you here in green?
B.
B is our answer. Ryan, thanks for playing. That's good stuff. All right. If we can finish this page, I'll probably leave you guys alone, but that would be 2 pages that we took care of your review. So I think that would feel really good. This is a question straight off one of our quizzes, I believe. Determine whether the pair of lines, this one right here, and this one here, are parallel. Please understand, in order to be parallel, we need to have the same slopes. Perpendicular, this is another question. In order to be perpendicular, our slopes need to be opposite reciprocal slopes. If our slopes aren't either one, then we're going to choose neither. Does anybody know the slope of this first line here? Reese, do you know the slope of that first line? Negative x plus 2y equals 6. Do you know the slope of that first line, Reese?
No.
I don't either. That's actually a really good answer. Do you know the slope of the second line?
No.
Oh, I know the slope of the second line. Do you know how I know?
Why?
Well, there's a way an equation can be written. I don't know if you remember, slope-intercept is y equals mx plus b. All right? If y is all by itself, if we have the equation solved for y, then the number sitting next to x is the slope. So on this second line, what is the slope of this line?
2x.
Well, it's not. So it's the number sitting next to x.
2.
Yeah. the slope of this line is 2. Now, Reese, we can't do that on the first one. Do you see that this equation is not solved for y? We do not have y all by itself.
Yeah.
Do you think, in your brilliance, could you help me take that equation? It says negative x plus 2y equals 6. Could you help me get y all by itself?
Yeah.
How would we do that? Because right now, I have several things over here with y. I want y all by itself. What's something that you could move to the other side of the equation?
Probably back to, or
Well, I would want to eventually move the 2, but I'll give you a hint. We want to move this negative x to the other side. How do I make it so that this negative x is not here anymore?
add x on both sides.
Brilliant move. If I add x, that will cancel this out. Now, if I add x to the other side, let's rewrite the equation and see where we're at, Reese. What's left on this left side?
2y.
Yeah. I still got the equal sign right here. What's on the right side?
Is it 6x now?
Is
or is it 6 plus x?
Which one? Because 6x would be multiplication. 6 plus x is addition.
So 6 plus x.
Yeah, it's addition right there. So we're close. I got to get this y all by itself. How do I get rid of that 2?
Subtract it.
I would totally agree if I saw addition in between these two. But what operation's in between 2 and y?
Multiplication.
Yeah, it's multiplication. So if I want to move the 2 to the other side of the equation, I'm going to use the opposite operation, which would be what?
Division.
Yeah, so if I divide by 2, I got to divide everything by 2. I got to divide the 6 by 2, and I got to divide this x by 2, which is not very easy, but you got rid of the 2, which we're down to just y. Do you know what 6 divided by 2 is, Reese?
3.
And then x divided by 2, did you know that there's a 1 in front of x that we don't normally write?
Yeah.
Well, do you know what is 1 divided by 2?
2.
Careful. It's a half, yes. So we have a 1/2 and an x. So what's the slope of this equation now that we have y all by itself?
1/2.
You got it. The slope is 1/2. The question is, Reese, are my 2 lines, first off, are they parallel?
No,
Why not?
they're not the same.
Yeah, I don't have the same slope, so I'm not going to choose parallel. What about perpendicular? Are my slopes opposite reciprocals?
No.
Well, let's go ahead and see. If I took the number 1/2, what's the opposite reciprocal of 1/2?
Wouldn't it be like negative 1/2?
Close. This one's positive, so I totally agree with your negative idea. That's the opposite. Now, how do I do a reciprocal?
Flip it.
What was that?
Would you flip it?
Yeah. So if it was 1/2, I got to flip it, and it becomes
2/1.
2/1. So the perpendicular idea would be a negative 2/1. Is that what the other slope is? Is this a negative 2? No, so I have to eliminate perpendicular. Which option do you think I should choose, Reese?
Neither.
Makes sense, doesn't it?
Yeah.
Reese, you crushed that. That was awesome. All right, we got 4 left. So a line has this equation. Who wants to help me solve this one? Because they are asking for the slope, and we need to find a perpendicular slope. I need someone who can help me do what Reese just did. I got to take this equation, and we need to solve for y. Beatrice, have you made it back? Come on, Beatrice. Don't hide. Talk with me, Beatrice. We got stuff to do today. Man, it's gonna be tough if you. I don't want you hiding from me. Lilith, you got to help me solve this for y. I know you know how to do this, Lilith. Okay. I got to get y all by itself, so I got some items to move to the other side. What do you want to move first, Lilith?
2x.
Heck yeah. How am I going to get rid of it?
Subtract 2x from both sides.
I could not have said that any better myself. If I subtract 2x on both sides, you got rid of the x's on the left, which leaves me with what?
Negative 4y.
And what do I have on the other side of the equation?
6 minus 2x.
Love it. We're close. I want y by itself. What do I got to do?
Divide both sides by negative 4.
Yes. Now I got to divide everything by negative 4. So I'm down to just y. Do you know what 6 divided by negative 4 is? It's not an easy question, is it?
Negative 1.5, I think.
No. Is it 1.5? Did a 1 and then
Think.
yeah, negative. I don't have any problem with decimals. Negative 1.5. Now, what am I going to get if I do a negative 2 divided by a negative 4?
Negative 1/2.
What's a negative divided by a negative?
Positive.
Yeah,
7/2.
positive 1/2 x. So what's the slope of this line now that I've done all that? You've done all that work. I didn't do nothing.
1/2 x.
Okay, so careful. The slope is the number next to x. The slope isn't x. So the slope is what?
1/2.
Yeah. Now, but they didn't ask for the slope of this line. We got to find the slope of a line that's perpendicular to that one. What do I change this slope into? Did you see what Reese just did a problem ago right here?
Yeah.
We need to find the opposite reciprocal of that number.
Wouldn't it be the same thing, negative 2 over 1 or negative 2?
Yeah, I was going to say, if you already have the work over here, I was wondering what the big pause was, but hey, sometimes I'm tricky, right? So what are we going to choose? A, B, C, or D, Lilith?
C.
We got it. We must have done well because Mr. Spake is silent. 54, what relationship between the slopes of two lines is needed to show that the lines are perpendicular? Choice A says there's no general rule as the y-intercept is different. One slope is negative, the other is positive. Will they have the same slopes? Or one slope is the opposite reciprocal of the other? We better know the answer to this. If we're even following along. I don't even know if Frank or Beatrice is even following along with us. Victoria, I know you know the answer to this, Victoria.
Is the perpendicular one the one that like goes across, like one goes down and the other goes horizontal?
Well, if we had the definition of perpendicular would be two lines that intersect to form right angles. So for certain, we're going to have one going downhill and we'll have one going uphill. I totally agree. But how do I choose? They're asking about the relationship between the slopes of perpendicular lines.
Okay. I don't think it's A.
Yeah, there's certainly some relationship, right?
B. I think one could be negative, right?
Well, so think about slope. Slope is how we measure how steep something is. If we're going downhill, that's got to be a negative number. If we're going uphill, that's got to be a positive number.
Okay, so that's a possibility.
So B is a possibility. What about C?
Definitely not.
Definitely not. And then what about D? One slope is the opposite reciprocal. What the heck does this mean?
I have no idea.
Oh man, have you been hanging around with us for a while? Because I don't know, to the last two problems, we've been applying the opposite reciprocal,
Oh.
which has had a relationship between, that was our relationship for perpendicular lines.
Oh, okay.
You gonna go with B or D?
I would pick D.
I would too. D for duh. I'm glad to have you back in class. This is good. All right. Problem 55, using the figure at the right. We need to create an equation involving x. This is the first two questions on the review, so you guys might not have seen that if you haven't started the review yet. But this is our old conversation of parallel lines and a transversal. I'll give you a recommendation. If you want to solve for x, don't involve the y. But if we look at this angle and this other angle that we know down here, the 142 degrees, anybody think they can classify these angles? Quicker we come up with an answer, the quicker I'll stop talking. I bet, Allie, come on, can you classify those two angles for us, Allie? Do you remember all of our classification options?
Oh, yeah. Those two are same side.
Well, we're trying to remember, we had, our options were corresponding, alternate interior, alternate exterior, same side interior, same side exterior.
Same side exterior.
Yeah, and you remember the importance was if we classified, that led to an equation or a relationship. The same side interior, the same side exterior angles were always going to be what?
Supplementary.
Supplementary. What does that mean again?
That they equal 180 degrees.
They will add up to equal 180 degrees. So that leads me to an equation, right?
Yes.
What's the equation that I can write?
4x plus 6 plus 142 is equal to 180.
Do you think you're able to solve that? What's the first thing that you would do, Allie, to try and solve this for x?
I would combine the like terms, so I would combine 142 and 6.
And that combines to make what?
148.
I like that first move. What's your next move?
Subtract 148 from both sides.
I could not have said it better myself, and I've been teaching for a while. You don't want to grow up to be a teacher, do you, Allie? Don't say yes, because you go on. I want you to make a lot more money than me. You go ahead. You get out of here. Mr. Spake and I will hold the fort down. You go make a ton of money and don't forget about my car, okay? Okay. So if we take away 148 from both sides, I believe that leaves us with 32 on the right side. What's your next move?
Divide both sides by 4.
I really hope you know what 32 divided by 4 is. That's what I got. Of all these answers to choose, should we choose A?
No.
Only if we want to do silly things. Fantastic job, Allie. Now, the only question, the tougher idea, if you ask me, is coming up with an equation that'll help us solve for y. I think that's tough, but that's just me. Leo, you got any idea how we can come up with an equation for y? Because that's tough.
Alternate interior angles are the same, aren't they?
Alternate interior angles would be the same, but this y, the one that involves y here, is way on the exterior.
Alternate exterior.
Ooh, those all I would agree that 3y plus 31 and 142, those are alternate exterior angles, which means what equation could we set up? Because remember, classification leads to a relationship. If alternate exterior angles are going to be congruent, what equation could I write that would relate 3y plus 31 and 142?
3y plus 31 equals 142.
3y plus 31 would have to equal 142. If we can solve this, we're home free.
Awesome.
How do we solve this, Leo?
The first thing I would do is minus 31 off of the left side and then minus 31 off the right.
Yeah, Leo and I would do the exact same thing. We would both subtract 31 from both sides. That'll get rid of that 31, leaving me only with 3y.
And then you're basically on the last step, which is
142 minus 31, what do you got?
I need a calculator.
You do need a calculator? Well,
11.
oh, maybe it's 111. Maybe it is. We'll see. And then, so how are we going to get rid of that 3?
You do 3y divided by 3 equals y, and then 111 divided by 3 is what y equals.
Do you know if 3 goes into 111 evenly?
It probably doesn't.
There's a trick. Do you want to know a trick? Any number, watch this trick, Leo. Can you add up all the digits to this number? What do they all add up to?
3?
Does 3 go into that number?
Yes.
Then 3 goes into this number.
Oh, I don't like that.
It works every time.
Horrible. What about with like single digit numbers?
It still works. I mean, 3 goes into 3, 3 goes into 6, 3 goes into 9. But like if I gave you the number 71,246. 7 plus 1 is 8, 10, and another 10. The digits add up to 20. Does 3 go into 20?
No.
No. So 3 won't go into this number evenly either. There's some good tricks for numbers, so I highly recommend that we choose option A here. You guys remember, you got to complete this review if you want the big 10-point bonus. And be careful, the last page, it's a lot of definitions, all right? And don't think, oh, I don't have to do that page, because I put in the instructions here, define the following terms. Must be completed to earn all possible points. I actually want you with your own hand to go define all of those terms. They're easily findable. You can either utilize your notes or Google it. I don't care. But you need to refresh your relationship with all of those terms and definitions that we've had throughout the semester. If you get all of that done and you turn it in on time, I'm going to highly reward you. So please make sure you're getting all of this work done. If you have any worries or concerns, feel free to get in touch with me.